This video is over lesson 93, dividing polynomials, and it's for my Algebra 1 class. So ladies and gentlemen, when it comes to dividing polynomials, we have three different methods that we're going to take a look at in my class. There are more out there. When you get to Algebra 2 in particular, you will more than likely learn another method called synthetic division, which is a nice little shortcut. We're not going to worry about that right now. But just so you know, there are more methods out there, but we're going to focus on three here. And so the first one that I'm going to focus on is going to be dividing specifically by a monomial. And to make things really easy when you're dividing by a monomial, it becomes very easy if we can use the distributive property to do this. Now, it's not always going to work nicely, but when it does work nicely, it can be very quick and simple. And let's just give that a little prominence there. So dividing by a monomial using the distributive property. So in red pen, what I'd like you to do here is please copy down this example. And so I copy it in red because this is what your book might say. Actually, probably wouldn't have. Yeah, it should actually have parentheses there. So one thing that I want you to understand here is your book is going to have some typos in it. Without the parentheses here, that should mean that we are only dividing by 4, and then we'd be multiplying the result then by x. So really should have parentheses. Your book often, though, if this is just a single term, will leave off these parentheses. And so they still intend this to be grouped as one term. So understand that if you see this in the book without parentheses around the 4x, they do intend that to be grouped as one term. So just a heads up that that may come up on the homework. Don't get thrown off by that. So if this is what I see in the book, though, I'm usually not going to write a division symbol. So what I would do is when I go to copy the problem is I would actually convert this into a fraction. Now here's the thing. Just like multiplication will distribute over addition and subtraction, division also distributes across addition and subtraction, meaning that this 4x can divide into each one of the terms above to produce an answer. So as long as 4x goes nicely into each of these, the distributive property can be a really nice shortcut for this. And sure enough, it does. So if I divide this by 4x, well, 8 divided by 4 is 2. X cubed divided by x would just be x squared. Over here, 12 divided by 4 would be a positive 3. And x squared divided by x would just be a single x. And then finally, 4x divided by itself would be 1. So again, the key to the distributive property is the denominator is going to go to each of your terms above. It will go to each of the terms above, not just some of them, not just part of them, the whole term. So this works nicely if this over that simplifies, and this over that simplifies, and this over that simplifies nicely. So that's dividing by a monomial using the distributive property. That's our first method, nice and simple. Second method here, and let's go ahead and skip 2 lines just to give that a little bit of breathing room, is going to be dividing in general, so not just when it comes to monomials, but dividing by some other polynomial. So monomials, binomials, and beyond. And this is going to be using factoring. And we've actually been kind of doing this already. So division using factoring. I'm going to borrow the problem up here again one more time. I'm not going to bother writing it in red pen again. So if we consider what we could factor out of each of these, well, it should be pretty obvious that a 4 can be factored out of each of those. And so that'll leave behind a 2 and a 3 and then a 1, which we're going to hold off on the 1 because if there was anything else there, then the 1 would disappear. And then I would factor out whatever I can. So with an x cubed, an x squared, and an x, I can factor out an x. That'll leave behind an x squared. That'll leave behind an x, and then nothing for the variables, so that really will be just a 1. And then likewise, it should be pretty obvious then my 4x will cancel with my 4x. And again, that leaves me with 2x squared plus 3x plus 1. It just takes a little bit more work to show it, but the same idea. So if you're feeling a little nervous about the distributive property, you could just go back to factoring like we've been practicing for a while now. All right, we're going to take a look at another one here. This time, we're going to have x squared plus 4x plus 3, and we're going to divide that by a binomial. So again, it might look like that in the book. If it looks like that in the book, first thing we're going to do is we're going to convert this into division written as a fraction, because that's what we tend to lean towards in Algebra 1 and beyond. So if I divide this using factoring, I'm going to look at the top here and I see, okay, this is of the form x squared plus bx plus c. So remember, I need something times something, that's 3. And then those two somethings have to add together to get 4. Well, that should be pretty obvious, because 3 times 1 is 3, but 3 plus 1 is 4. On the bottom, I have x plus 1. Now remember that denominators can be treated as just a full quantity. So this x plus 1 quantity will cancel with that x plus 1 quantity. And then we can go ahead and simplify that down to just x plus 3. So that's division using factoring. And we could do more factoring, but that's the idea. And then the final technique that we're going to take a look at here, so skip a couple lines, and this is going to be long division. We can divide polynomials using long division. So for our first example, we are going to take a negative 25x plus 3x squared plus 8. And we're going to divide that by an x minus 8. So the very first thing when it comes to long division, though, is when I put it in my division box, standard form is needed. So when I put it in my division box, we need to make sure that we write this in standard form. So my first expression goes in the box. So my highest degree is this square. So 3x squared will go first. So there's my squared term, my quadratic term. Next would be my linear term. So a minus 25x. And then the last thing is my constant. Extend that a little bit. And then out front, I have x minus 8. Now, one of the things that we need to understand is in normal long division, you have columns. So for example, if I were to give you, let's say, the number, the division problem 6 into 108, let's say. My answers up here will have place values that will match the place values here in the box. So whatever goes up here, we're saying we have that many groups of 100 sixes. This would be the tens place, so 10 groups of sixes. And then finally, this would be the ones place, so just plain old groups of sixes. So we would ask ourselves, how many times does 6 go into 1? And when we put a 0 up here, what we're really saying is that there are 0 groups of 100 sixes. I mean, think about 100 sixes would be 600. So can you get a group of 600 in here? Well, no. That's why it's a 0. So when I come over here and I look at this and I say, okay, how many times is 6 going to 10? I put a 1 up there. This 1 is in the tens place. So we're saying we have one group of 10 sixes. Well, 10 sixes is 60. So can you get 60 into 108? Yes, we can. So that's why we put the 6 down here. And what we often skip just to make it easy is this really is a 60. But because there's a 0 there, it's not going to affect that 8 at all. So that when I do my subtraction here, it's really like 10 minus 6 is 4. And then this is where we normally bring down this 8 because 8 minus 0 is still just 8. And then we finish it off by saying, all right, now we're in the ones place. So how many just sixes will go into 48? Well, 8 sixes. 8 times 6 is 48. So we have columns. We have a hundreds column, a tens column, and a ones column. And in a similar fashion here, we're not going to have a ones, tens, and hundreds column, but we are going to have an x squared column. We're going to have an x column, and we're going to have a constant column. And those columns, because these are polynomials, will be separated by plus and minus. So if anything I put up here then has to be an x squared term. So that means that I need to take x minus 8 and then multiply it by something x squared. And my goal here is to get this. Well, x squared times x will be x cubed. That would be in an x cubed column, which we don't have. So this is going to be empty. So what does it take to get an x to be an x squared? Well, it's going to take another x. And then what does it take to take an x and turn it into a 3x squared? 3x. So just to recap what just happened here, the key idea is going to be, what will it take this x, to turn into 3x squared? That's the idea. So in order to get a 3x squared, I'm going to have to multiply by 3x. So now we're going to go ahead and subtract. So in order to do the subtraction, just like we did with our 6 over here, we take this number up top, multiply it with our 6 to get what goes here. So if I were to actually finish this problem off, since I had an 8 and a 6, 8 times 6 would have been the 48, which when we subtract we get 0, that's why we know it goes in evenly. So over here, I'm going to multiply this 3x times this binomial. So it's going to distribute. So 3x times x is going to give me that 3x squared that we wanted. Then 3x times a minus 8 will give me a minus 24x. I'm going to subtract this now. So my 3x squared and my 3x squared are going to be gone. And then a minus 25x minus a negative 24x. So minus a negative, this will basically be plus a positive. So negative 25 plus positive 24 will be a negative 1, or negative x. Then we bring down the next column. The next column is a plus 8. So now I'm down here into my constant column. So what constant would we multiply with x to get a negative x? Well, negative 1. So a negative 1 times x will give me a negative x. And a negative 1 times a negative 8 will give me a positive 8, which then, if we subtract here, something minus itself will always be 0. And so the 0 there, that's my remainder. Since the remainder is 0, nothing remains left over. That means it goes in perfectly. And so the answer to this division problem is 3x minus 1. Now, if that seemed a little strange to you, don't worry, we're going to do some more examples of this. If you're still struggling with these, please contact me or participate in one of our Zoom meetings. So, 3x minus 1 is the answer. Of course, just like over here, though, to check my answer, I can take my answer of 18 and multiply it by my divisor of 6. So 8 times 6 is 48, carry the 4. 6 times 1 is 6, plus 4 is 10. So that checks out. Likewise, I can also take my quotient, my answer, I'll get that out of my light spot there, and multiply it by the divisor. And so if this foils back to the original, then I know I've gotten it correct. And I'll let you do that on your own there. So there's one example. We're going to take a look at another example here. This time I want to take a look at two x squared minus 9 minus 7x, and we're going to divide that by a negative 4 plus x. Again, standard form is needed. So when I make my box here, so my quadratic term is the highest degree, that will stay there, but then the linear term should be next, followed by my constant term after it. Outside of it, I'm doing the same thing. I'm going to put my linear term before my constant. All right, the key idea is, what do I do to the x to turn it into 2x squared? So in order to make it a 2x squared, I'm going to have to multiply it by 2x. So that will go in the x column here. My 2x will go in the x column. So 2x times x is 2x squared. 2x times minus 4 is a minus 8x. We always subtract. So 2x squared minus 2x squared is gone. A negative 7x minus a negative 8x. So minus negative, that's basically plus a positive. So negative 7 plus positive 8 gives me a positive 1, well, or just x. And then bring down the next column. So I'll bring down my constant, so minus 9. So what does it take to make an x into an x? Well, 1. X times 1 is still just x. So multiply that by 1 then, and I get x minus 4, which we are now going to subtract. X minus x is gone. A negative 9 minus a negative 4, so basically negative 9 plus a positive 4, is a negative 5. And so what we end up here is with a remainder this time. Now, if we were to go back, and if I were to quickly redo this problem, just slightly modified, 6 does not go into 1, but 6 goes into 10 once. Subtract, I get 4, bring down my 9. 6 goes into 49 then, 8 times. 6 times 8 is 48. Subtract, I have 1. And my bright spot there is right on top of that. So 1. So remember, ladies and gentlemen, what do we do with this leftover here? Well, this leftover becomes a fraction. So this becomes the numerator of that fraction. The divisor is the denominator. Now, it's important here as we translate into what does this mean then for my my polynomial. It's important to understand that if you look at each of these place values, this 1 here really tells me that I have one group of 10. This 8 here really means I have 8 ones, and then we're adding on a 1/6. That's really what that number means. We just throw it all together and we combine it into a smaller form. So what this means for us over here, though, is anytime that we have a remainder, that remainder is going to be added or subtracted as a fraction to this quotient right there. So since this is a minus 5, a negative 5, I'm going to put a minus here. The 5 will be the numerator. The divisor is the denominator. And so this is my answer. 2x plus 1 minus 5 over the quantity x minus 4. So that's what we do if we end up with a remainder. All right, we're going to look at one more problem here. We are actually not going to find the answer to it, but we're just going to get it set up. So for this last example, we're going to go ahead and take a look at a negative 2x plus 5 plus 3x cubed, and we're going to divide that by a negative 3 plus x. So likewise this time, I'm going to put this in standard form. So highest degree monomial there would be my x cubed, my cubic term. So next should be the quadratic term, or the squared term. But if we look there, we don't see it. Now, if we go back to consider 109, we know that there's one group of 100, there's nine groups of 1, but the 0 here tells me that I have no groups of 10. However, my answer might have groups of 10 in it. So likewise, with polynomials, we have to have every column. Every group has to be covered. So because I'm missing an x squared here, we are going to have to write in plus 0 x squared. So if there's ever anything missing in there, when you do long division, you are going to have to add that in as a 0. Now after the x squared, the quadratic term, will come my x term, or my linear term, which I do have that, negative 2x. And then finally we'll finish it off with the constant, plus 5. Outside, I'll set up in standard form my binomial, and then we'd be ready to go ahead and divide. And so my first step here would again be to say, all right, x, how do I change that into a 3x cubed? Well, it's going to take a 3 and an x squared, which means that the first part of this work would be multiplying by 3x squared, which is why we need that x squared column. And I'm just going to put a dot, dot, dot there to say we're not finishing it, just that gets it started. So again, don't forget, no missing columns. You got to have them in there. So with that, all that set up, I'd like you to please grab your books and open up to page 620. Page 620. And we're going to take a look at the practice problems together quickly. So for A, I'm not going to bother writing it the way the book has it. I'm going to write it in standard form as a fraction. So there's my numerator. And then again, technically, there should be parentheses around the 7x squared. Without having the parentheses, it really should just be a 7 down here and then an x squared next to this. However, they intended you to divide by 7x squared. So even though they've written it wrong, we're going to do it right. We're going to learn the math even if the book is wrong about its writing. So quick look here. I'm dividing by 7x squared by a monomial. Can I use the distributive property for this? Can I distribute a dividing by 7 to each of these nicely? Can I distribute dividing by x squared to each of these nicely? And the answer to both of those is yes. So I will. If I divide this by a 7x squared, the 7's will cancel and become 1's. And then x to the 4th and x squared would just become x squared. 7x cubed divided by 7x squared will leave me with just an x behind. And then finally, in 84 divided by 7 will give me a 12. And then the x squared and the x squared will just cancel each other out. So the answer to this is x squared plus x minus 12. B. Copy it down. I'm going to copy it as a fraction. So x squared minus 10x plus 25. All of that over x minus 5. So this one might actually be easy enough to go ahead and just use factoring. So I'm going to try factoring this one. Well, as I look at it, I see the back here is the square of something. It's the square of 5, which means it's also the square of a negative 5. And then if I took an x and a negative 5 and multiplied those together and doubled it, I would get a negative 10x, which means that the numerator of this actually is a perfect square trinomial. It is of the form of a squared plus 2ab plus b squared. So a would be x, b would be a negative 5, so double their product, a negative 10x. So that means that this is really x minus 5 squared over x minus 5. Well, obviously the x minus 5 will cancel one of them from the square, leaving us with just a single x minus 5. C. I have a 3x squared minus 14x minus 5 over an x minus 5. So for this one, we might be able to do some factoring to figure this out, but since that's not readily obvious, I'm actually going to choose long division on this one. I'm going to choose long division. So I'm going to go back. 3x squared minus 14x minus 5. And then I'm going to put the other one in standard form. So in standard form, it would be a negative x plus 5. So for my answer here, remember we always start with what do we have to do to a negative x to turn it into a 3x squared? Well, first of all, I'm going to have to multiply it by negative 3. The negatives will cancel, and that'll get me my 3. And then I'll have to multiply by an x in order to get an x squared. So a negative 3x is what I've got to multiply that by. So that goes in the x column. And so if I go ahead and multiply that, a negative 3x times a negative x will give me a 3x squared. And then a negative 3x times a positive 5 will give me a negative 15x. Which then, if we subtract, 3x squared minus 3x squared will cancel, that's gone. A negative 14x minus a negative 15x, so negative 14 plus a positive 15 would be just a positive x. Positive 1x or positive x. Bring down my minus 5. Now what do you have to do to a negative x to turn it into a positive x? Well, multiply by negative 1. So negative 1 times a negative x will give me a positive x. And a negative 1 times a positive 5 gives me a negative 5, which of course if we subtract something minus itself, that's always 0. So it goes in nice and evenly. And my answer is a negative 3x minus 1. Remember that we should be able to FOIL the divisor and the quotient in order to go back to the original to check our answer. Moving on to D. D is going to require us to use long division. So we already got a little practice with that. We're going to do more with it now. So for letter D, my dividend in standard form starts with a cubic term. So I've got a cubic term. Next I'm looking for my quadratic, which is 8x squared. After that we go on to linear. 20, not 2. 20x. And finally my constant, which as I take a look at it, I don't have a constant there, so I will just put a plus 0 there for my constant. My divisor is an x minus 2. And now we're ready to divide. So if we go ahead and divide this, what does it take to make an x cubed? Well, it takes x squared. So that x squared times x is x cubed, and x squared times a negative 2 would be a minus 2x squared. Subtracting minus a negative will be like plus a positive. So an 8 plus a positive 2 will be a positive 10x squared left over. Bring down just the next column. And so now I'm looking, what would it take to turn an x into a 10x squared? Well, it'll take a 10 and another x. So plus 10x in the x column. So 10x times x will give me a 10x squared. And then a 10x times a negative 2 will give me a negative 20x. So we go ahead and subtract those, and we get 0 because they're the same thing. And with a 0 left over, there's really no point in bringing down that plus 0, which means my answer is x squared plus 10x. Skip a line, letter E. For letter E, we're going to put things in standard form. So I have a cubic term of 6x cubed. My quadratic is a 3x squared. I have a linear that's just x, and then finally a constant that is a minus 33. For my divisor, I have an x minus 2. So what does it take to turn an x into a 6x cubed? Well, 6x squared. 6x squared times x will give me my 6x cubed. And then 6x squared times a negative 2 will give me a negative 12x squared. Those will cancel, but then a minus a negative would be like plus a positive 12. So negative 3 plus positive 12 would be a positive 9x squared. Bring down my x now. What does it take to turn an, oops, sorry, I gotta move that up a little bit. So what does it take to turn an x into a 9x squared? It's going to take 9 and another x. So plus 9x. 9x times x will give me my 9x squared. So when I subtract, those will cancel. And then a 9x times a negative 2 gives me a negative 18x. Subtract. Those will cancel. Negative 18 will be like plus a positive 18. There's one x there, so positive 19x plus, oops, sorry, minus 33. Gotta remember that's a negative 33. Bring down that minus 33. And now to finish it off, what does it take to turn an x into a 19x? Well, it's just going to take 19. So that 19 times x is 19x. And then 19 times a negative 2 would be a negative 38. 19x minus 19x will cancel, plus a positive. So a negative 35 plus positive 38 would be a 5. Since I have a remainder, remember we're going to add that remainder on as 5 over x minus 2. So that is my answer to that long division. And to finish things off, let's take a look at G. We're going to skip F, and we're just going to move on to G. Carlos wants to find the width of his rectangular deck. The area is x squared minus 10x plus 24 square feet. So notice they do put parentheses around the polynomial and then the units afterwards. That means that technically those units would distribute to each part of the polynomial, but it's just easier to put parentheses and leave the units at the end. So that way you don't have to write them 3 times, one for each term. You can just write it once at the end. And the length is x minus 4 feet. What is the width? So for this one, we could do this using long division, or we could practice factoring one more time. So for this one, I'm going to say let's go with factoring. For one, I'm running out of space on my paper, and 2, it seems like it's going to be easy enough to do. So if you know the area and you know the length, we should know that we're going to take the area and divide it by the length to find the width. So that this is going to be x squared minus 10x plus 24. And then we're going to divide that by x minus 4. Factor the numerator. I'm looking for something times something that's 24. That when I add them together, I get a negative 10. So since this is positive, we know that these are going to be the same sign. So both positive, both negative. But since they add together to become negatives, they got to both be minuses. So x minus something and x minus something. From there, well, 6 times 4 is 24. And if I make them both negative, it'll still be 24. But when I add them, I'll get a negative 10. All over x minus 4. So that quantity will cancel that quantity. And therefore, the width is x minus 6 feet. And that, ladies and gentlemen, is our lesson.